Hello student, are you there? ඉන්නවද නැත්නම් මම ටිකක් කළා හිටපු නැති හින්දා කට්ටිය ගිහිල්ලාද?
Yes, sir. Yes, good afternoon, sir.
Good afternoon. Sorry, there was a delay. First today we had a Senate meeting, so it was delayed, and now there's a construction going just off the lab. So time to time you might hear some drilling noise, so please bear with me. I'm trying to find another lab to move. So until it is settled, you'd have to do with this background noise, right? So that day we were discussing about basic digital electronics, about circuit component. Before doing that, I think you're having your CAT 1 exam next week, right? CAT 1 එක තියෙනවනේ next week නේ මම හිතන්නේ මේ සතියේ.
Yes, sir.
Right. So we will follow the same format. That means 3 questions. You would have to answer all the 3 questions. The generic areas would be something like this. You would get something from the analog electronic component, and another component, another one will be from either analog or some sensor or something related to that. Last one will be from the digital electronics, but the starting part, right? So whatever you have covered up to today will be the digital part, and not anything from today, what we are covering today. Basically, let's say up to today. So some of the basics, not anything from today onwards, right? කියන්නේ අද එකත් එක්ක පොඩ්ඩක් බලා ගන්න. ඊට අමතරව ගොඩාක් එහාට යන්න අවශ්‍ය නැහැ. ඒ ටික CAT 2 එකට තමයි out වෙන්නේ, right? එතකොට analog එකෙන් තමයි main components, right? So mainly from the analog components. So the idea is you have to know the theories behind them. There were very few equations. You have to know that few equations, nothing major. But mainly you will have to know how to apply what you have learned. That means basically about designing a circuit. I mean, if you learn about the different levels of learning, the bottom layers are about memorizing things, reading things, writing things, and in the middle you have calculations. In the top you have something like analyzing and designing. So as special students, that's what we will be focusing on. But don't worry, this will be based only on things I have told you. If you look at some past papers, you might have seen that sometimes I give you open-ended question and ask you to design a circuit. So there's more than one way to do it. That's perfectly okay. You can go ahead with your knowledge and design a circuit for this, right? So that's about the paper, upcoming paper. I uploaded the previous, the week before the previous lecture into the WhatsApp, YouTube, and send you the link. Anything we want to ask about the exam? Exam එක ගැන මොකක් අහන්න දෙයක් තිබේද?
So I think we haven't done relay switches.
Sorry?
We haven't done relay switches.
Relay switches.
Yeah.
Yeah, today I will cover about that one as well. So today what I want to cover is, okay, we have the digital electronic part as well. Basically about binary number system and sensors, including the relay switches. We have covered the binary, you have covered the, what do you call the rotary encoders, right? I think you have covered the rotary encoders.
Yes.
Okay.
Yes.
And including binary encoding and the gray encoding. So what we can do is, give me a second. Okay, I just uploaded the next the video on the last week. So I'll put the Zoom link as, sorry, not the Zoom, YouTube link. But please note it's still processing, so it might take some time before you can access that particular video. Right. It's good that Harin had mentioned about relays. We have forgotten about that relay part. So let me quickly explain what the relay is and how it works. Then we will go to the binary number system. So in the very first lecture, we talked about how to use switch. There are different types of switches, SPDT, DPDT, toggle switches, push buttons like that. But they are all used by humans or some other mechanical force. They are not controlled by electric current. A relay is a special switch which is controlled by the electric current. How does it work? Well, its behavior is quite simple. What you have is you have an electromagnet, right? You call it as L1. You have electromagnet, and there's a thin metal strip like this. And there are two more metal strips connected like this. These ones, the ones I draw in blue, are stationary, they are fixed, they can't move. However, this other one, the one I draw in, let's say red, this one is flexible, it can move. Now what happens is, if there's no power to this particular relay or this power, this particular coil, the current can conduct like this in this direction or the other direction. Therefore, this particular terminal is known as the normally connected terminal or NC. This is known as the common terminal. This is the normally connected terminal. Now let's say we applied some current to this particular relay. Now what's going to happen is this current will cause this electromagnet or the coil to be magnetized. Therefore, it will attract, it will attract this term, this particular metal strip, and it will connect it to here. So now the current will flow. There's a path from here to here. So if the current is not flowing, you will have a connection like this. When the current is flowing, it will connect to a different terminal. So this terminal is known as the normally open terminal or NO. T is for the close, O is for the open. So it's basically like a two-way switch. In a two-way switch, you have two different paths to select. Usually you can manually select one of these paths, but here the selection is done by a electric signal. So what is the advantage of using a relay? Now, obviously, a relay can be used to control a larger current from a smaller current. For example, there are different voltage relays. You have 3 volt, 6 volt, 12 volts, 24 volts, and 230 volt like that. Usually, this voltage is the voltage applied to the coil, electromagnet. But if you look at the relay case, you can see this particular voltage. In addition, you might say something like 230 volt, 5 ampere, something like this. This second part usually apply for this switching component. That means you can have a 230 volt current going through this NC and common terminal or NO and common terminal up to 5 amperes. So this means we can control a larger voltage and a larger current using only a small voltage. For example, 3 volts mean you can use just 2 AA batteries, right? Using them, let's say you have another switch and you have a relay coil, and here you can connect a 230 volt bulb. So by on and off in this particular switch, you are effectively controlling this 230 volt large bulb. So that's the main use of a relay, controlling a large current and a voltage from a very small amount of current or a voltage. But there are some disadvantages of relays. Can you think of some disadvantages? මොනවද relay එකේ තියෙන පුළුවන් ප්‍රශ්න? Now remember, this is a mechanical switch. So when you have a mechanical switch or a moving part, what can happen? Mechanical in the sense you have a moving parts. But if you look at a diode or a transistor, you don't have any moving part. This is a moving one. So what can be disadvantages of having a mechanical moving parts? Mechanically හෙළ වෙන එකක් තියෙන එකේ මොනවද වෙන්න පුළුවන් ප්‍රශ්න? හිතන්න බලන්න. Any idea? Yes, that's one thing. You can have sparks. So one negative point is you can have sparks. Another negative thing is the speed is limited. I mean, if it's a transistor or something, you can switch maybe few hundred kilohertz speed, right? Few hundred times per second, maybe 1,000 times per second. But if you have a mechanical switch, you can't move that fast. It takes some time to move it, so it's a bit slow. And it also degrades with the time. And it also has a bit noisy. You might have heard that if you have in certain cases, maybe in some vehicles, when you make the turn signal, sometimes you will hear a ticking noise. Sometimes with the wiper moving here and there, you will hear a ticking noise. That means there's a relay that's latching, and that make a noise. So that's a bit noisy. So those are the most common negative effect of it. On the other hand, the positive things are they are relatively cheap and they are isolated. What do you mean by that? There are components that can do the same thing, especially in semiconductors. For example, you can use a transistor or a SCR, right? You have a transistor like this, you give a small signal and you control a larger one. If you have a SCR, you give a small signal, let's say 5 volts, and you are controlling a 230 volt load. But the problem is, these are not physically isolated. They are still in the single silicon wafer, right? So if something happens, there's a chance the 230 volt might come into this direction as well. So safety-wise, there's a small concern if they are not fully isolated. But if you look at a relay, now relay is a different design. You can clearly see there are two different circuits parts here. Right? You have one circuit here, which is a inductor, and you have another circuit here, which is the main control. And they are isolated, right? There's an air gap and there's a barrier. That means there's almost no chance of this 230 volt ever coming to the conductor. Right? So that's another advantage. They are fully isolated. There's another disadvantage, but we can reduce that disadvantage. That disadvantage is electromagnetic field induction. What do you mean by that? Sorry, back EMF, back electromagnetic field induction. Now, if you look at this is a coil. An electromagnet is basically a coil. That means a wire wound around some kind of ferrite or iron rod. So it also acts as an inductor, right? It also acts as an inductor. Now, the property of the inductor is, if you try to push the current, it will try to oppose it. But when you are already having a flow of current, if you try to stop it, it will try to regenerate it. Right? So The problem with the relay is when you try to switch off its current in the coil. Let's say you have a switch here. Your relay was on. Now you try to switch it off by removing or cutting the power of this particular line. When that happens, this inductor or this coil actually generate a current across the coil. So it's basically EMF generation. So that can damage the other components. But this can be very easily solved. The way we solve it is we apply or we connect another diode in parallel to the relay. So let's say this is our relay, so negative watt. This is our inductor. We connect a diode like this across the coil of the relay. So when you are supplying the current, since the diode is reverse bias, so all that current will go through this one. But let's say when you switch it off, then still this inductor try to generate the current, but now it will go through the diode like this and discharge, right? So that's another important thing you have to remember. Now, relays can be, there are another variation of relays. Usually what you see is a relay with a single SPDT kind of thing. That means you have a single pole and double throw. But in some cases you have a DPDT type. That means when the relay is active, relays, when you put the current together, this line will connect it to these two lines. When the power is not there, it will connect to these two lines. So it's basically like a DP-DT switch. Okay? That's basically like a DP-DT switch. Any questions regarding the relays? Relays ගැන මොකුත් අහන්න ප්‍රශ්න තියෙනවද? relay එච්චර අමාරු subject එකක් නෙමෙයි. ගැටලු මොකුත් තියෙනවද අහන්න? Okay. I will ask you to do a small exercise. This one is using relays. Now, recently our lab designed a buzzer system. I hope you know what the game show buzzer means, right? You have a button like this at the top, and there are some copies of it, and there are some participants like that, and there are some participants. The thing is now there's a, it's basically a quiz show. So when the person or the announcer asks a quiz, a person tap on the buzzer and the light goes on. Once it's on, no one can switch on the other's light. Only the person who had tapped the buzzer will have the chance. So let's try to design a part of this, a very simple part of this system. So the idea is you have to have a buzzer system, not a system, a single buzzer. Once the button is pressed, a light should switch on. Let's say this is the light. It should switch on. Even if you remove the hand, the light should kept switched on. Now there are so many ways you can do it. You can do it using SCR, you can do it using transistors, you can do it using flip-flops, you can do it using a microcontroller, so many ways. But I want you to do it using relays. Do you get what I'm saying? There should be a push button. Let's say it's a normally open push button. So that means when you press it, current start to conducting. And there's another bulb. If you just connect the bulb to this one, the bulb will only switch on until you are pressing the button. I don't want that. Once you press the button, the bulb should keep switch on even when you remove the hand. That's the idea. ඒ ප්‍රශ්නේ පැහැදිලිද? මොකද්ද මම ඔයාලට හදන්න කියන්නේ කියලා ඔයගොල්ලන්ට? ගැටලුව පැහැදිලිද?
Yes, sir.
Right. Then can you quickly design that? In කවුරුත් ඉවරද? Prasad, are you finished?
So here, do we need to use a transistor as well?
No, only using relays.
Since the current given by the push button is very small, do we need to amplify it?
You can use the relay to control a larger current from a small current. In addition, assume that this is a small bulb. The main functionality I'm looking is it's a push button, but even when you release it, the current should flow. That's the main function I'm looking from this particular circuit. තේරෙනවද? ඒ කියන්නේ අපිට මේක මේන්ලි මට මේකෙන් කරගන්න ඕනේ පුෂ් බටන් එක අතෑරියත් දිගටම කරන්ට් එක යන්න ඕනේ. අන්න ඒ දේ කරන්න පුළුවන්ද බලන්න. Anyone having any progress?
So I'll take a photo and share it.
Sorry?
I want to take a photo and share it.
Sure, sure.
So I shared it in the chat.
Banana. Harini, assume you have only one power supply, and as I mentioned, the main function is to keep the bulb switched on, not about amplifying the power, right? Because the way this one is working, I don't think it will work. While the button is pressed, the bulb will on, but after that, it will not switched on. So single power supply. So don't worry about amplifying it. Try to use this as try to build a circuit similar to a toggle function. Not actually a toggle, part of the half of a toggle. So when you press it, it kept switched on, even when you release it. The key point here is to make sure the current flows even after you have released the button. Okay, I will leave it as homework. I think it's taking some time, but try to do it. It's not hard as you think. Anyone who want
Sir,
to?
can you check my one?
Yeah, that's what I was wondering. If you have finished, please.
Sir,
Yes.
can you check my one?
Did you put it to chat or how?
Strategies.
Can you share it?
Yes, sir.
Do you have two relays?
Yes, sir.
Okay. So can you explain the behavior? You can do it with a single relay. So then the circuit will not be isolated, but the functionality will be there. Can you explain, Patum, how this one works?
Okay. When press button is pressed, first relay works,
Right,
and then current pass to the second relay,
right,
and it worked, and then second switch off close,
right,
and then current pass continuously.
right. When you release the button, what's going to happen?
Release button. Uh,
Then you have an issue, I think.
yes.
Yes. So better give another try. Anyone else? Okay. How does this one work? I think, Sama, you have the same issue now. When you remove the finger from the button will switch off, right? So when you press the button, the buzzer sounds or the light switched on. That makes sense. But when you remove the button, remove the finger from the push button, when you release the push button, it resets back. That means the sound will stop. Now that's not the behavior I want. Once pressed, it should keep sounding the alarm even when you remove the finger.
Okay, so I'll try them.
Okay.
So I have a problem here. So once we give the current using the push button, will this coil work with that smaller current?
If there's no current going through the coil, it will not work. You should find a way to continuously send the current to the coil if you want to keep the coil magnetized.
Okay.
Okay, until you can do it in the homework, as I think, because we are running a little bit late. What we can focus on now is about some basics in binary number system. Why do we need it? Because last day we learned about binary number addition, so we just got on touch with it. But sometimes you need to convert large numbers into binary. So how do you do it? Let's say now there are different types of number representations. You have things like sign and magnitude and unsigned. You have a floating point. You have ones complement and twos complement. So like that, there are so many ways you can represent numbers using binary. But I'm going to keep it very simple and limit it into unsigned number format. What is unsigned? We can expand it to fractions as well. So I'm not going to say unsigned integers, so it's unsigned numbers. Unsigned means the numbers will always be positive. In this scheme, you have no way of representing negative numbers. But this is the most common way or the easiest way to represent numbers. As long as they are not negative, you can use this mechanism. This is not the most efficient way to do it, but the easiest way to do it. Let's say you have a decimal number like this. In everyday, now, although we say 325, you can also decompose into something like this. 10 to the power 0, 10 to the power 1, 10 to the power 2. So 10 to the power 0 means 1, 10 to the power 1 means 10, 10 to the power 2 means 100. So this means if you multiply 1 into 5, 5 ones, 2 tens, and it should be 100, 300. That is how this number is made from, right? 325. Because you have a place value. This number system has a place value. Similar thing can be applied for binary number system. Let's say you have a binary number like this. 0, 1, 1, 0, 1. Then this will be 2 to the power 0th place, 2 to the power 1st, 2 to the power 2nd, 2 to the power 3rd, and 2 to the power 4th. So when you solve it, you have 1, 2, 4, 8, and 16. So you have 1 in the 1th place, you have 1. You don't have anything in the place where you represent 2. So this will be 0, plus 4, plus 8, plus 0. You end up with 13. So this is in binary format. This is in the decimal format. So this is how you convert a binary unsigned number into a decimal. Even if you have fractional values, you can still do it. Let's say you have something like this. You have a binary point here. Can someone calculate and give me the equivalent decimal value for this one? Make it having decimal value here. Here then make a decimal value. What is the place value of this one? 2 to the power 0, right? This is 2 to the power 1, 2 to the power 2, 2 to the power 3. What about this one? If you have a decimal number system, what will happen? Let's say you have 73.21. So this is 10 to the power 0, 10 to the power 1. What is this one? and this one. What is the value here? The place value?
So minus 1.
2 to the power
10 to the power minus 110. 10 to the power minus 2 or 1 in 100, right? This is when you have a decimal number system. So when you have binary, what should you have here? 2 to the power minus 1, 2 to the power minus 2, and 2 to the power minus 4. So these in terms will be half, 1/4, and 1/8. So if you want, you can write it in like 0.5, 0.25, and 0.125. Then what is the number you are having? Here you have two, you have a 2 here, plus 4, so this one part becomes 6. Here you have this one, so this becomes 0.325. So this together you end up with 6.325. Right? That's I think you understood that part, right? ඒක පැහැදිලි නේද කරන්නේ කොහොමද කියලා? ඒකේ ගැටලු මොකුත් තියනවද?
Yes.
Now, if you want to convert 35 into binary, how are we going to do it? What's the value? When you convert 35 into binary, give me the number.
One 0 0 1 1.
Okay, what about others? How do we convert this into a convert this into decimal? We start by dividing it, right? So 17, which end up 34. And remain this one. Then you divide it again, you end up with, sorry. We'll use the other notation, that will be easier. Not the long division, the short division. This will be 117, remain this one. Then this one will be 18, remain this one. Remain this 0. And then we start writing it in this direction. End up with 1 0 0 0 1 1. We can check it here because we have 1 here. This one will be 2 4 8 16 32. So you end up with 32 plus 3, which is 35. So this is how you convert a binary number, sorry, a decimal number into a binary. Even if you have fractional part, you can still convert it, but then the method is slightly different. Rather than dividing, you will have to multiply it. Let's say something like 0.125. We want to convert it to binary. So what we do is we first multiply by 2. You end up with 250 right here. Then you again multiply by 2. 0. Then you again multiply by 2. End up with a 1. So you end up with, by going through it like this from this point, 0.001. Not 0.01, this is 001. That's the binary one. If you look at something like 300.375, then when you multiply it by 2, you end up with 0. Then you multiply it again by 2. Now 1 here. Then you again multiply by 2 because you have 0.5 here. Then you have everything 0, so you can write it as 0.011. That is how you convert fractional values into decimals. Even if you have a number like, let's say 6.375, you convert this using the first method and convert this part using the second method, and then you put the binary point and connect them together. That is the idea of doing it. For the binary number system, I'm not going into much details like 2's complement or anything. This should be sufficient for you at the moment. Any questions you want to ask? Okay, if there are no questions, let me go to the other part in the lecture. Now we have been discussing about digital electronics, and last day we learned about half adders and full adders. There are two types of digital electronic circuits that you can have. Some of them are custom circuits that are designed based on your requirements. Some of them are standard circuits. Now, half adder and full adders are standard circuits, so you should know how to build them and also the truth tables and things like that. The next part, the next component set that we are going to learn is again some of the standard circuits. The first one we are going to learn is called the encoder. Or to be more precise, this is called a simple encoder. Now there are different types of encoders. The one we are learning is called the simple encoder because it's basically a very simple mapping. Function of an encoder is to map one pattern into another pattern. For example, you can have a SSD encoder where you convert a binary number into a SSD number. SSD stands for 7-segment display. So when you give a binary number, it displays it in the correct binary format. Sorry, 7-segment format. Here we have a different scenario. You have multiple inputs, but there's a condition in that input. That means at a given time, only one of the inputs can be true. All the other inputs should be false. So you can see that limits the number of possible combinations drastically. For example, if you have only two inputs, there are only two possible combinations. First one is true, or the second one is true. You can't have a scenario where both of them are true or neither of them are true. Because the condition for the simple encoder is there's always one and only one true value in the input. So if you have, let's say, 6 different inputs, there are only 6 possible combinations. First one is true and all others are false. Second one is true and all others are false. Third one is true and all others are false. Likewise, you have 6 possible combinations. For each combination, you can assign a binary number. Right? Since the binary number patterns is larger than the number of inputs, smaller than the number of inputs, you can basically compress this into a less number of bits. So here's a simple example. Here's an example of a simple encoder. This one you see is called a 4 to 2-bit simple encoder. 4 to 2-bit means you have 4 inputs. That means there are 4 possible ways you can input the signal. One of these 4 channels will become true, while all the other 3 will become false. So there are 4 possible ways. Those are mentioned in the truth table. Now, if you have 4 rows, or if you have 4 possible combinations, 4 can be represented using only 2 bits. Right? In other words, 4 possible combinations can be represented using only 2 bits, but then you don't have that condition. If you are representing it using only 2 bits, you can't say only 1 bit will be true at a time. You can't say it. You are basically trying out all possible combinations. So mapping of these 4 channels, where only one and only one become true, into a respective binary number is the function of a simple encoder. Here you can see I have the inputs, you have 4 inputs, and here's the respective outputs. For these circuits, we usually draw a block like this, a rectangle, and put the name on it, rather than showing the internal digital circuit. The reason is these are built-in blocks, so when you are connecting these things to create a more complex circuit, you don't want to make it more complicated than it is. You want to represent it as simple as possible. Inside can be complicated, but since your representation is simple, it's easy to understand. So this is the symbol for a 2-bit encoder. And how does it work? Now you can see, if you apply the conventional way of converting that we learn how to convert truth table into a binary expression, then you will realize that it can be a little bit lengthy before you simplify it. The reason is when you are having just the method I mentioned in the previous day is a more generic one. Now here we have a special condition saying only one input can be true. Therefore, you can create a circuit much simpler than that. Here you can see if the A is 1, X and Y should or both be 0. In other words, you can look at it in this way as well. If you want X to be 1, it will be true if C is true or D is true. In all the cases, all the other cases, X will be 0. Similarly, Y will become true only in these 2 occasions. That means only if the B is true or D is true. So like that, you can see, we can very easily design a circuit like this. So example, this output X. Now output X become true if and only if you have the C input as true or the D input as true. So you can see, okay, C and D, they are together. They should be the X input, okay, X output. If you have C and D together, then you can have this gate. If you have B and D together, like this, it's this output. right? So this X and Y should interchange. That is what a 2-bit encoder basically does. It looks at a pattern as I mentioned earlier and convert into a binary number. Now, decoder is the opposite. Now, decoder looks at a simple this is again a simple decoder. It looks at a binary pattern and convert into another pattern. Now, input pattern is a binary number. So that means it can have all the possible combinations. If you have 3 inputs, that means you can have 8 different combinations, 8 different rows. If you have 4 bits as the input, you can have up to 16 different rows. Now let's see you have 3-bit input, so 8 different rows. The output is same as what I mentioned in previous. So that means if you have 4 rows or 4 combinations, you will need to have 4 output lines for a simple decoder. At any given time, only one of the outputs will become true. One and only one become true. So you can have a binary pattern like this. So when you got 0, 0, output D become true. When you got 0, 1, output C become true. All others are false. When you have 1 and 0, this become true. All others are false. When you have 1 and 1, only A become true and all others are false. Right? I hope you understood this concept of simple encoder and the simple decoder. එන්කෝඩ් එකේ කරන්නේ අර මම කලින් කිව්ව බයිනරි පැටර්න් එක. ඒ කියන්නේ එකපාරට එක වැලියු එකක් විතරක් ට්‍රූ වෙන එකක් අරගෙන ඒක බයිනරි නම්බර් එකකට මැප් කරනවා. ඩිකෝඩ් එකේ දෙන එක අනිත් පැත්ත බයිනරි නම්බර් එකක් අරන් ඒක එක අවුට්පුට් එකක් විතරක් ට්‍රූ වෙන විදිහට මැප් කරනවා. ඒතකොට එන්කෝඩ් එකේදී ඉන්පුට් එකේ පින්ස් ගාන වැඩි, අවුට්පුට් පින් ගාන අඩුයි. ඩිකෝඩ් එකේදී ඉන්පුට් පින් ගාන අඩුයි, අවුට්පුට් පින් ගාන වැඩි. Is it clear? පැහැදිලිද එන්කෝඩ් එකයි ඩිකෝඩ් එකයි? තේරුණාද නැත්නම් ඒක පැහැදිලි මදිද?
සර්ගේ ෆන්ක්ෂන් එක ආවම කියන්නේ
එන්කෝඩ් එකේදී කරන්නේ මේ වගේ ඉන්පුට් පැටර්න් එක. දැන් ජෙනරලි එන්කෝඩ් එකක් කියන්නේ පැටර්න් එකක් තව එකකට මැප් කරන එක. සිම්පල් එන්කෝඩ් එකේදී කරන්නේ මෙන්න මේ කිව්ව විදිහේ පැටර්න් එකක්. ඒ කියන්නේ ඉන්පුට්ස් ගොඩක් තියෙනවා. හැබැයි එකපාරට එකයි ට්‍රූ වෙන්න පුළුවන්. ඒක බයිනරි නම්බර් එකකට මැප් කරනවා. බයිනරි නම්බර් එකම එතනදී එකපාරට එක නෙමෙයි එකපාරට ගොඩක් ට්‍රූ වෙන්නත් පුළුවන්. එකක්වත් ට්‍රූ නොවි තියෙන්නත් පුළුවන්. ඩිකෝඩ් එකේදී වෙන්නේ ඉන්වර්ස් එක. බයිනරි නම්බර් එකක් අරගෙන එකපාරට එකක් විතරක් ට්‍රූ වෙන එකක් ඔන් කරනවා. හිතන්න මෙහෙම දෙයක්. Right. Now think of something like this is a hypothetical example. Let's say you have 10 students. Each one has some bulb in front of him. If you want to, let's say, ask a question from a particular student, you light up the bulb of that particular student. Let's say 16 students, right? Now, if you want to wire it directly, you will need to have 16 different wires, right? 16 different switches, 16 different wires, one for each student. So that will be a little bit costly, but there's an easier way you can do it. You can use something like a decoder, right? Here you input only the binary number. So 16 can be represented using only 4 bits. So you wire only 4 wires, and at the student's end, you have a decoder which expand that 4 wires into 16. Right? 16. So when you say, okay, number 3, you input 0, 1, 1, number 3. Then the third student's light will switch on while all others remain switched off. Right? So this is something like that. You have a binary input. It is mapped to a output where only one of the outputs can become true.
yes sir.
Now here's a small exercise for you. I want you to create a circuit for this decoder. I want you to design a digital electronic circuit for the decoder. Do it for this one. That means 2 bit to 4 line simple decoder. Okay. When you finish, you can share the screen, or you can send a photo to the chat. Okay, I think Sama and Haran had submitted and the answers are correct. So what you basically have is something like this. For example, if you look at this one, where you have only the B's as true, it would only happen when X is 0 and Y is 0. So you can have a not here, and use an AND gate. That's the only place where B should become true. And similarly, if you want to have C, it should only happen when X is 0 and Y is 1. So you can say X bar dot Y, that's the output of the C. So if you directly map it, you will end up with something like this. But if you want, you can simplify it further by removing these two, or you can say these NOT gates are becoming common, because here you are taking Y bar, here again you are taking Y bar. Here you are taking X bar, here again you are taking X bar. So whenever you want to have a X bar and Y bar, rather than having a separate NOT gate, you can have the NOT gates at somewhere at the top. So then you will have this number of gates and have something like this. So what I'm saying is in your circuit, you have X and Y as inputs. And in some cases, you have NOT gates like this. And some cases, you don't have NOT gates. So rather than putting NOT gates here every time, what we can do is we can have a NOT gate here, a single NOT gate. So this will be X bar, this will be X. Similarly, we can have another NOT gate here. This will be Y bar and this will be Y. So after that, if you want, let's say X and Y bar together, you can have this one and this one. If you want both X bar and Y bar, you can have the Y bar here and the X bar here. So that way you can reduce the number of gates by taking now this common NOT gates. Right. Now this is the decoder circuit that you learn. Design a combinational circuit to function as a 7-segment decoder. Map the binary input to display the correct number on the SSD module. Okay. This is the last activity I'm going to give you for today. In the simple decoder, you had a very simple mapping where you convert one where the input is only one is true to a binary number. Now I want to do something a little bit more complicated. I want to convert a binary number into a SSD output. I hope you remember what, not remember, I hope you know what the SSD is. It's basically an LED display. The difference is you have multiple segments. We have 1, 2, 3, 4, 5, 6, 7 main segments. That is why it says 7-segment display. But in fact, you have 8 where you have a decimal point here. But we rarely see that one. No, it is already there, but we still call it as a 7-segment display. By lighting up different LED segments. Now, those 7s are actually 7 different LEDs that can be individual light up. So we label them as A, B, C, D, E, F, and G. This is known as H. So we have both these inputs A, B, C, D like that. Up to H. And by lighting up these segments, we can create different numbers. For example, if I don't have number 3, I will light up this segment, this segment, this segment, this, and this. Then you will see that's number 3. So in this question, what I'm asking is, you have a binary number. Now the maximum you can go up to here is 9 in the decimal place, because you can't have a 10. So to have a 10, you need to have another SSD, right? So you can go up to only 9. That means you can represent all the numbers that that can be displayed in a single 7 segment display using only 4 bits. So you have 4 bits. So that means in the 4-bit you can write 0, 1, 2 up to 15, but you don't go up to 15 here, you end up with 9, right? You end up with 9. So for this one, input will be something like this. This one will be 0, 0, 0, 1. This one will be 0, 1, 0. So you have an input like this. And if you want to display 0, 0, 0, you can check which segments to light up. For example, A should be 1, B should be 1, C should be 1, like that. But G should be 0. If you want to display a 0, you have to light up these things. So G should be 0, but others should light up. If you want to show number 1, like this, then which segments light up? A should not light up, but B should, C should, others should not light up. So you can see now we kind of have a truth table. This is our input, and this is our output. So that's the circuit I want you to design. So you have 4 inputs coming here like this. You have your decoder circuit, 7 outputs going like this, which connects to the 7-segment display. So when you represent a number using binaries, 0, 0, 1, 0, something like that, the respective value should be displayed here using the SSD display, 7-segment display. Is it clear? ප්‍රශ්න පැහැදිලිද?
Yes, sir.
Right. So can you quickly give it a try? By the way, there are 2 different types of 7-segment displays, common anode and common cathode. The one shown here is a common cathode. So that means if you give a 1 or a positive, let's say 5 volts, the segment will light up. Right? So what you have to do is BCD to 7-segment decoder. Right. Give it a try. See if you can find it. Anyone finished? ඉවර කරපු කවුරුත් ඉන්නවද? ඒක චුට්ටක් දිග වෙයි වැටට වඩා. හැබැයි ඕගලන්ට අර මම මුල්ම දවසේ කියලා තිබු මුල් දවසේ නෙමෙයි. ගිය සතියේ ලෙක්චර් එකේ කියලා තිබු ක්‍රමේ පාවිච්චි කරන්න පුළුවන්. ඒ කියන්නේ ට්‍රුත් ටේබල් එකක් හදලා ට්‍රුත් ටේබල් එකෙන් බූලියන් එක්ස්ප්‍රෙෂන් එක අරගෙන සිම්ප්ලිෆයි කරලා සර්කිට් එක හදන්න පුළුවනි. Right. So with that, I wish to wind up today's lecture. Any questions you want to ask? අහන්න ප්‍රශ්න තියෙනවද? Anything regarded to Cat1 or anything? ප්‍රශ්න මොකුත් නැද්ද?
So I have a question about that. The question you gave on the very first day about that Amal's question, where he wants to control the light intensity. So there also we need to use the relay switch, right?
If you want to convert a signal into intensity, then you have a small issue. The thing is, relay is like a binary switch. It can be either on or off. It can't be somewhere in the middle. Okay. So
Yes.
depending on the condition, if you want to just switch it on or off, you can use a relay. But if you want to dim the switch, dim the bulb, then you can't use a relay because relay won't stay somewhere in the middle. Then you have two options. One is you can use a op amp to control the voltage. So that's the easiest way to control the light level, because you might have seen if you have a incandescent bulb or what you call as a filament bulb, when the voltage is low, you get a dim light, something sort of like reddish light. Then the intensity is low. But when you heat it further, you get a much more brighter light. That's one way of doing it. But let's say you have a LED bulb. Then the way you do the intensity control is usually called as a PWM. But what it basically doing is you are switching it on and off very fast. So our I see it as a continuous light, but the intensity is low. For example, let's say you are switching it on 1 millisecond and switching it off another millisecond, alternatively very fast. Then the light is actually on for half of the time. So intensity will be half. So that's another way of controlling the light intensity. But on the very first day, the question I gave you, we did not discuss about PWM or anything. So for that one, the easiest solution would be to control the voltage. But when you learn about oscillators or something like that, then you can use the PWM technique as well. Or if you have microcontroller section, then you can use that as well. But a relay cannot be used to control the intensity because it's either a switch as on and off, and you can't do PWM because you can't switch it on and off fast enough.
So while using the thermistor, while using the thermistor, how can you use how can you change the light intensity?
Then you have not the thermistor. I think what you are referring to is the LDR, right?
LDR.
Right. Using the LDR, then you can use a op amp to map the whatever the voltage to the required voltage you first get the voltage level of the LDR, and for that light intensity, for that voltage, there should be a some amount of light that is required. You can do that by finding the, or you can mapping it basically with the voltage. So you are basically doing is you are mapping the LDR light intensity to voltage supplied to the bulb. So if it's too dark, the bulb will get high voltage. So the light intensity will be high. If it's only slightly dark, then the voltage supplied to the bulb will be low. So the light intensity of that bulb will be low. So you have to use a op amp or something like that to do that conversion, because you can't directly connect the LDR to the bulb. Are you there?
Thank you, sir.
Right. then we will finish. Oh, අහන්න.
Can you share analog presentation to start?
රෙකෝඩින් එක තිබුණ නැද්ද? හම්බුනේ නැද්ද?
Presentation එක ගන්න පුළුවන්.
ප්‍රසන්ටේෂන් එක පොඩ්ඩක් එන්න මම දාන්න. මේක fully complete නැහැ. නමුත් ඔය ඉල්ලපු section ටික මම හිතනවා මේකේ තියෙනවා කියලා. හරි. වෙන මොකුත් ගැටලු නැත්නම් අදට අපි මේක නවත්තමු. ඊට පස්සේ අපි